This is S plus lambda L equal to 0. We can write this is the family of circles from the IP topics. So angle between the tangents. Angle between the tangents. I'm taking a tangent of the external point of the circle from plane. So like this. So then, so we have to find the angle between the tangents. Okay. So we can prove this one as per the triangles. Then we can get this value tan theta by 2 equal to r by root over s11. Tan theta by 2 equal to r by root over s11, where s11 is the point. Just to substitute the s equal 0, then so we have s equal 0, just you have to substitute the equation. Then x square plus y square plus 2gx plus 2fi plus c equals 0. Then the s11 is nothing but x1 square plus y1 square plus 2gx1 plus 2fi1 plus c equal to 0. Then the angle between that tangents from the p is nothing but tan theta by 2 equal to r by root over s11. Okay. Next, if two tangents are perpendicular, then s11 equal to r square. So s11 equal to r square. So what is saying? Two tangents are perpendicular like this. So I'm taking this. Okay, this is the tangent. So then this is, then s11 equal to r square. So just you have to check that one. Next, PA and PB. So PA, PB are the tangents to circle S equal 0 with the center C. Then circumcenter of the triangle PAB is the midpoint of CP, and the circumradius is CP by 2. So what is saying here? Please observe this. So this is a tangents I'm drawing. So like this. So just touching here, take like that. So this is a P. So what is saying that then the circumcenter. So here C is there. So I'm the second. So circumcenter of triangle PAB. So this is, so this is chord of contact. It's like, so that is a midpoint of CP. So midpoint of CP. I'm taking midpoint of CP. This is the circumcenter, and the circumradius is nothing but CP by 2. CP by 2 is, this is nothing but here, this value. Okay. Next, area of the quadrilateral formed by two tangents drawn from an external point to a circle and a pair of radii through their points of the point p x1 comma y1 with respect to the circle s equals 0 is 2r into under root of s11 by root over s11 by s11 plus r square. So what is saying that here the area of quadrilateral formed by the two tangents drawn from an external point. So external point. So and a pair of radii So like this. So this is the point P. So this is touching the circle. This is like this. I'm writing like this. So then this is center. So this is A. This is B. Then area of this value. We have to find the area of this value. So area of the two tangents drawn from the and the pair of radii. Then with respect to s equals 0. So point x1 comma 1, that is the P value outside of the circle. Then the area can be find with this formula. 2r into under root of s11 by s11 plus r square. Okay. Next, s equals 0 is a circle in a standard form with the center C and the radius r. If the p x1 comma 1 is a point, then the area of the triangle formed by the pair of tangents from P and a chord of contact of P is. So here, so same, but the difference is, so with the chord of contact. So I'm taking like this only. So this is a, so we can take like this. So just touching points, this line passing to the touching points. So I'm taking, this is A and this is P, this is B. So in the previous discussion, in the previous formula, so this is the quadrilateral PACB is a quadrilateral. I'm taking triangle here. PAB is a triangle. Here PAB is a triangle. Then I have to find the area of the triangle formula. This is, so then use this formula for find the area of this triangle. Okay. So this is the important concepts. Some one more concept will be there. So next, observe this figure. Yes, this is. Okay, this is the, just we have to find the this area PAB. So for that one, r into s11 power 3 by 2 by s11 plus r square. Okay, next, so relative positions of two circles, relative positions of two circles. Let C1 C2 be the centers and the R1 R2 be the radius of the circles, s equals 0 and s dash equals 0 respectively. So we are taking C1 C2 and the R1 R2 the centers and the radius of the respective circles, s equals 0 and s dash equals 0. So then, so here first, if C1 C2 is greater than R1 plus R2, then two circles do not intersect, then we can draw four common tangents. So here clearly see this is the condition. Observe this one, C1 C2 is greater than R1 plus R2. C1 is the center, C2 is the center of circle 2, this is the center of circle 1. Then R1 is the center of radius of the circle 1, and this R2 is the radius of the circle 2. Then the relation between those two centers, distance between, and the distance formula from this one, so add this one. So then two circles do not intersect. When this one, two circles do not intersect, then we can draw four common tangents. So four common tangents are there. So see, observe this figure. So here C1 C2 or the center for the respected circles, and the P is any point outside of the these two circles and the external point. So that is circle 2 meeting at A, circle 1 meeting at B, and the circle EF, and the 2 is E, and the 1 is F. So this is point P, and draw a sun. So here, once again, see here, this is center. So we have a radius R1. We have a radius R1 for this circle. So and this is center 2. So this we have an R2 center. So here these lines are common tangents. Common tangents. So these brown lines and the black lines are called as tangents, common tangents. So these brown lines are brown lines and black lines common tangents. These black lines are called as transverse common tangents. Black lines are called as transverse common tangents, and the brown lines is called as direct common tangents, DCT, direct common tangents. So here I'm saying that from the passing through the P, from this figure, I'm saying that from passing through the P is called the direct common tangents to the circles. Okay, and from the passing through the Q, that are called as the tangents is called as transverse common tangents. Okay, next, so going to this one. So C1 C2, where is C1 value is here, C2 value is here. Just you have to find that this distance, so C1 C2, so you have to find the distance between the 2 points is nothing but under root of x1 minus x2 whole square plus y1 minus y2 whole square. Then you will get the value of that one. So and again he mentioned here R1 plus R2. So we have the value of R1 up to here only from this one. So this is R1, so this is R2. So this is greater than, this is the x greater, so more value than the R1 plus R2. That's why the two circles do not intersect. The two circles do not intersect. This is a concept. Okay, so next, if C1 C2 equals R1 plus R2, then the two circles touch each other externally, then we can draw three common tangents. So here circles touch each other externally. Okay, C2 C1 and the P. So here I'm an external point, I'm taking, this is a direct common tangents, this is common tangents, transverse common tangents. Only we can draw three common tangents from here. Okay, so this is C1 C2 equal to R1 plus R2. This is the length, is R1. So I'm taking, this is R1 R2, sorry, here R2, I'm taking here R1. So I'm taking here R1. So this is distance between the centers. Then the two circles touch each other externally. Circles touch either externally. We can draw three common tangents from this one. Okay. The point of contact P divides C1, C2 in the ratio of R1 is to R2. So here, this line. So here C1, P, C2 are the collinear points. Okay. So and this P divides C1, C2 in the ratio of R1 is to R2. R1 is to R2. Okay. If mod of R1 minus R2, this is the distance, R1 minus R2 is less than C1, C2. So take this condition first. Is less than R1 plus R2, then the two circles intersect each other. Then we can draw two common tangents only for to the circles. So observe this. These are two circles. We can draw like this. Okay. So this is here R1 minus R2. So this is R1 value up to here. So R2 values up to here. R1 values up to here. So this is less than 2 C1 C2. So distance between those two. Then the two circles intersect each other. Intersect at 2 points each other. So we can draw only 2 points from the external point. Only two common tangents. Only two common tangents from the external point. Okay. So then here, see this. Now observe this. C1, C2 is less than R1 plus R2. R1 plus R2. Then same as it is. C1, C2 value is less than R1 plus R2. So then same also this will be. Okay. Next. If C1, C2 equal mod of R1 minus R2, then the two circles touch each other internally. Touch each other internally. Then we can draw common tangents. How many? Only one common tangent. We can draw common tangent here mentioned. Common tangent to the circles. So we can draw common tangent to the circles. Only one common tangent. Okay. So here C1, C2 equal to mod of R1 minus R2. Then the two circles touch each other internally. So if C1, C2 equal to R1 plus R2, that is externally. Okay. So then that time we can draw three tangents. Now this time we can draw only one common tangent. Okay. So the point of contact P, C1, C2 divides C1, C2 in the ratio of R1 is to R2 externally. R1 is to R2 externally here. So this is, I'm taking P. So like this here. So this is C1, C2. So this point P divides C1, C2 externally in the ratio of R1 is R2. This is R2 ratio. So this is R1. So this is externally formula. Okay. Now, if C1, C2 is less than mod of R1 minus R2, then one circle entirely lies inside the circle. One circle entirely lies inside the circle. Then we cannot draw common tangent to that circles. We cannot draw common tangents to the circles like this. So we cannot draw any tangents to these two circles. Common tangents. Okay. Common tangents to these two circles. So two circles with the centers C1, C2 and the radius R1, R2 touch each other if this is the first C1, C2 equal to mod of R1 plus R minus R2. Mod of R1 plus R minus R2 if touch each other. Okay. Next. Center of similitude. Center of similitude. So the point of intersection of direct common tangents. The point of intersection of direct common tangents of two circles called as external center of similitude. See this. See here. Point of intersection of direct common tangents. What are the direct common tangents here? So these brown lines are direct common tangents of of two circles, and the P is called external center of the similitude. So this is external centers. So out of this is external of the C1, C2. So we can write that one. So if the point of intersection of transverse common tangents of two circles is called the internal center of similitude. This is called internal center of similitude. These dotted lines. So this is transverse point of intersection of transverse common tangents. This is internal center of similitude. Okay. So this is nothing but, if I am taking, this is C1 and this is C2. Here the P is there and the Q value is here. So then, so this is called as external center of similitude. This value is nothing but internal center of the similitude. So that is saying that from the definitions. So the internal center of similitude Q divides C1 C2 in the ratio of R1 is to R2. So what is saying here? So here C1 C2, this is Q. So internal center of similitude Q divides C1 C2 in the ratio of R1 is to R2. R1 is to R2 ratio. The external center of similitude P divides R1 is to R2 externally. This is internally, this is externally. This is externally. From the point of trisection, we know that. Okay. So the circle with the center of similitudes as a diameter is called the similitude. Circle of similitude. The circle with the centers of similitudes as a diameter is called the circle of similitude. Okay. Next, length of common tangent. So length of common tangent, if D is the distance between the centers of the two circles whose radii R1, R2, then the length of the direct common tangents. So direct common tangents, I'm taking this is length of direct common tangents. So this is there. No? So this length of direct common tangents are, so, and D value is the perpendicular distance, and R1, R2 is the radius of the first circle and the second circle. So D square minus, that is the length of the common chord of two circles, is AB equal to under root of D square minus of R1 minus R2 whole square. R1 minus R2 whole square. Next, and length of the transverse common tangent of two circles A dash B dash, I'm taking, that is under root of D square minus R1 plus R2 whole square. R1 plus R2 whole square. We can use these formulas. So this is the direct common tangents used for the length of the direct common tangent. This is using for length of the transverse common tangent. Okay. Next, problems. The circles. What is saying that? The circles x square plus y square minus 12x plus 8y plus 48 equals 0, x square plus y square minus 4x plus 2y minus 4 equals 0 are what is the options is there? Intersecting, touching externally, one lies inside the other, touching internally. So these are from the options we can find C1 C2 relation between the C1 C2 and the R1 plus R2 R1 R2. So just we have to find that one. So here what is the C1 value is there? So C1 I'm taking C1. So this is 6 comma minus 4. Okay. R1 equal to under root of 6 square is nothing but 36 plus 16 minus 48 then we'll get this value is a 4, that is nothing but R1 value is 2. Okay. So this is under root. So this is 52 minus 48 is nothing but 4 under root 4 is nothing but 2. Then C2 this is 2 minus 1. So then R2 value R2 equal to 4 plus 1 plus 4, that is minus 4. Then you will get this value as 3. 9 root 9 value is 3. So then we have to check C1 C2 equal to R1 plus R2 R1 plus R2. So so intersecting means what we have, C1 C2 is equal to mod of R1 minus R2. This we have first we have to check this one. So C1 C2, C1 C2 is nothing but distance between this one. So 2 minus 6 is nothing but 4, 4 square is nothing but 16, minus 1 plus 4, minus 1 plus 4, 3 plus 9. So this is a root under root C1 C2 value. This value is 25, that value can be written as 5. So in the R1 plus R2 is 3 plus 2 is nothing but 5. So then, so 5 equal to 5, C1 C2 equal to R1 plus R2 existed. So that is touching externally, touching externally. So if intersecting means this value mod of R1 minus R2, this value is greater than. Okay. So lies inside means, so does not exist here. Touching internally means we have know that C1 R1 mod of R1 minus R2, so less than R1 R2. So that formulas we can use. Okay. So this is the second option is the correct one for this question. So this is a basic question, touching externally. So verify C1 C2 equal to R1 plus R2, then you will get option 2 is the correct option. So this is next one. The number of common tangents to x square plus y square equal to 256 and the x minus 3 whole square plus y minus 4 whole square equal to 121 is. So from the number of common tangents, we have to find the number of common tangents for this one. So then we can find the C1 value same as it is in the previous, but the number of common tangents. So when it is touches each other, does not touch each other internally, touching internally, one lies into other. So then we have the common tangents. How many? So does not touch each other. That is C1 C2 is greater than R1 plus R2. Then we have the 4 common tangents. If touch each other externally, we have the 3 common tangents. If touch each other internally, then we have 1 common tangent. If one lies in the other one, then we'll get 0 tangents. Okay. So then here C1 value. What is the C1 value? This is from the first equation 0, 0, and then radius R value is nothing but 16. So 256. R square value is x square plus y square equal to R square. Then this is the 16 value, and this value is the h comma k. C2 value is h comma k. Then this value is 3 comma 4 equal to then R equal to, so 121 is there, that is 11. Okay. So then you have to check C1 C2 equal 3 square, so 9 plus 16, 25 equal to, so this is 16 plus 11. So this is 16 plus 11. So I'm taking, so this is not, so 16 minus 11, 16 minus 11. So this value is of root 25. So this is 5. We can write 5. So then this is existing. So that is C1 C2 equal to mod of R1 minus R2, R1 minus R2. So then we can check that one. C1 C2 R1 minus R2. So this is, so then option 1 is the correct one. Option 1 is the correct one. So sorry. So this is option 4 is the correct one. So this option 1. So check once. This is. So I think typing mistake will be there. Though. So this is I think option 4 is the correct one. So typing mistake will be there. So internally. Okay. Next. If checking this one. So what is the question number 2? One common tangent will be existing for the previous question. So option 4 is the correct one. So here wrongly typed here. So this is a 4. Option 4 is the correct one. Option 4 is the correct one. Is it something? So I have to check that one. If the internal similitude of the circles x square plus y square minus 2x plus 4y plus 4 equals 0, x square plus y square plus 4x minus 2y plus 1 equals 0 divides the segment joining their centers in the ratio. So then, so what is the ratio? So we have to find the ratio of that one. So R1 is to R2. We have to find the C1 C2 equal to R1 plus R2. So here in the previous one we discussed about the external similitude and the internal similitude. From that one the ratio will be get, and the R1 is to R2 internally and the R1 is to R2 is the externally. So that one we have to find that one. So here R1 is to R2. We have to find just R1 is to R2. For that one R1 value. So R1 value is nothing but under root of center is nothing but here 1 comma 2, 1 comma minus 2, then 1 plus 4, 4 minus 4. Then the value is 1. Okay. R2, R2. So this is R2 value. So 2, 4 plus 1 minus 1 equal to 2. So R1 is R2 is nothing but 1 is to 2 ratio. So divides internal similitude. So internal similitude means this is the internal similitude. If the center C2 is there and the C1 is there, C1 is there. So the internal similitude means this value. So then you will get R1 is R2. You will get R1 is R2. Okay. So option 1 is correct one. Option 1 is correct one. So next, here the external center of similitude of the circles x square plus y square minus 12x plus 8y plus 48 equals 0, x square plus y square minus 4x plus 2y minus 4 equals 0 divides the segment joining centers in the ratio. Here in the previous one internal, now external. So then, so external means must and should this will be a minus R1 is to R2 or R1 is minus R2. So whatever it will be, just you have to find the R1 is to R2. Then first R1 value, then you will get R1 value is nothing but under root of R1. So this is a 36 center value 6 comma minus 4 plus 4 square 16 minus 48. So similarly this value is nothing but 4 is nothing but 2. So then R2 then under root of this value is 2 square is nothing but 4 plus 1 plus 4 plus 4. So then this is equal to 3. Then this is equal to 3. Then this value is minus 2 is to 3. Externally said that external center of similitude. So then, so 2 is to 3. So but the externally means that is a negative value. External means negative value. Then minus 2 is to 3 is the correct option. 2 is to 3 is the correct option. Okay. So option 4 is the correct one for this one. So then if two circles x square plus y square minus 8x plus 2y plus 8 equals 0, x minus 1 whole square plus y minus 3 whole square equal to r square intersect two distinct points at two distinct points, then r is greater than 2, r is equal to 2, r is less than 2, 2 is less than r is less than 8. Okay, for this one, go through the solution. So C1, C2 equal to R1 plus R2 here. So option 4 is the correct one. So here, observe this C1, C2. What is the C1, C2 value is here? C1 value is nothing but 4 comma minus 1. 4 comma minus 1. C2 value, this is 1 comma 3. 1 comma 3. And the R1 value, we have that R1, that is value is nothing but under 4 square 16 plus 1 minus 8. So 17 minus 8 is nothing but 9, 19 nothing but 3. So this R2 is nothing but R. R2 is nothing but R. So we have to check C1, C2 is less than R1 plus R2. So why the? Because of two circles intersect two distinct points like this. So that is the condition. C1, C2 is less than R1 plus R2. R1 plus R2. So from this condition, we get the value of this one. We get the value of R. So then C1, C2 value. What is the C1, C2 value? So he's mentioned this one. So C1, we have to use this formula. So C1, C2 is less than R1 plus R2. C1, C2, 4 minus 1. This is nothing but 9. 4 minus 1, 3 whole square. Okay. Minus 1, minus 3. So then 4 plus 16. 16. So is equal to, I'm taking now equal to, then 3 plus R. 3 plus R. So this is under root. So squaring on both sides, then you will get R value. Then you will get R value. So this is 25. This value is 9 plus 2R square. Then you will get a quadratic equation. You will get a quadratic equation. Then solve that. Then you will get R value as R2 is less than R is less than 8. 2 is less than R is less than 8. Okay. So solve this. Next, yeah, doesn't mean. So if the distance between the centers of the two circles of a rad A 3 comma 4 is 25, then the length of the transverse common tangent is 12, 26, 24, 13. Just to use the formula in the previous discussion, we have under root of d square. So this is what is asked, transverse. So that is nothing but under root of d square minus r1 plus r2 whole square. So which is under root 2. So then we have to find that one. So then, so this you can find the form. So option 3 is the correct one. So what is the d value here? D value is here 25. Okay. So then then you can solve from using that formula. Then you will get 24 is the answer. You will get 49 minus 25. Then you will get the answer. Okay. Option 3 is the correct one. So next, if the circles x square plus y square equal 2 and x square plus y square minus 4x minus 4y plus lambda equal to 0 have exactly 3 real common tangents. 3 real common tangents. From the question he mentioned 3 real common tangents means so touches externally. So like this. So I'm taking, so this is common tangents. 3 real common tangents, like, sorry for this one. So you have to draw like that. So then we have to find the lambda value. So then lambda value, what is the lambda value? So then C1 C2 equal to R1 plus R2 clearly says that 3 real components means C1 C2 equal to R1 plus R2. Then C1 C2 value, C1 value, what do you have to value? Find the value of C1 0 comma 0 and the R1 value. So that is root 2. So then C2 value is 2 comma 2, 2 comma 2. Then R2 value we have to find. So the lambda value we have to find, R2 value here. So 4 plus 4 minus lambda. 4 plus 4 minus lambda. Just to, from the condition of this question, C1 C2 is equal to R1 plus R2. So then, so just distance between these two C1 C2 value is 4 plus 4 root 8 equal to R1 plus R2 root 2 is there plus root of 8 minus lambda. I'm taking this value, root value to left side. So this value is root 8 minus root 2 equal to root of 8 minus lambda. Then squaring on both sides. Then you will get this value squares. So then 8 square, root 8 square is nothing but 8 plus 2 minus root 16, root 8 into 2 into 2ab, a minus b whole square, a square plus b square minus 2ab. And then 2 into root 16 equal to 8 minus lambda. So then you will get, so this value is 4 values, 8 plus 2 minus 2 into this is the 4, 8 value is there. So then this is equal to 8 minus lambda. So then 8 will get cancelled. Take the lambda into left side, this 2 value into right side. Then lambda, so that is 8 minus 2 is nothing but 6. So the lambda value is 6. Option 2 is the correct one. Okay. Right. Next, the center of the circle passing through the 0, 0 and the 1, 0 and touching the circles x square plus y square equal 9. Then is, what is the point? Touching point and touching the circle. So center of the circle. So passing through these 2 points and touching this circle. So then we have to find the center of that one. Okay. So this is center. If the required equation x square plus y square plus 2gx plus 2fi plus c equal to 0 and which is passing through the 0, 0, then you will get, what you will get? C equal to 0. And the required circle. So passing through 1, 0. So 1, 0 means 1 plus 0 plus 2g plus 2g, is it? 1 comma 0, 2g plus 2f into 0 plus c value 0. So 2g equal to 0, then g equal to minus 1 by 2, minus 1 by 2. So then this is g equal to minus 1 by 2. G value is minus 1 by 2. Then C1 value, what is the C1 value? C1 value from this equation, center C1 equal to 0 comma 0, and the radius of that circle is nothing but 3. Radius R1 equal to 3. Then I'm taking required equation is x square plus y square plus 2gx plus 2fi plus c. Then the center is nothing but C2 equal to minus g comma minus f, minus g comma minus f. Then so R2 value is nothing but R2 value I'm taking g square plus f square. So g square plus f square. Then g square plus f square. So that value we have to substitute there. So then g square plus 14. So then now R2 f g square plus 14. Where is this 14? Nothing. So then C1, C2 values, we find that one. So touching circles, touching means C1, C2 is equal to R1 plus R2. Just we have to check that formula. Then you will get G value will get that minus 1 by 2. So here from this one, we can take 1 by 2. Where is the options in the 1 by 2? First value, the center. This value is there, this value is there. So now we have to find the F value. For F value, just we have to find the C1, C2 equal to C1 C2 equal to R1 plus R2. Then from that one you will get that value is a root 2. Value is a root 2 plus or minus root 2. Then this is the answer. This is the required answer. Okay. 1 by 4. That is g square plus 1 by 4. This is 1 by 4. Then you have to solve that one. Then you will get f value is plus or minus root 2. This is the answer. So 3. Two circles with the radii R1, R2. R1 is greater than R2 is greater than or equal to 2. Touch each other externally if alpha be the angle between the direct common tangents. Then alpha equal to sine inverse of R1 minus R2 by R1 plus R2. Alpha equal to sine inverse of R1 plus R2 by R1 minus R2. Alpha equal to sine inverse of R1 minus R2 by R1 plus R2. So alpha equal to sine inverse of R1 by R2. So here just you have to draw the diagram. When you draw the diagram, so then you will get from right angle triangle, then you will get this value. So how is it, sir? So see, observe this one, this figure. So then like this. So from the centers, we have a draw tangents like this. So then we have a perpendicular here and we have a perpendicular here, but it has some, it forms some triangle here. It's a perpendicular line. This is 90 degrees. So that can be like this. That can be like this. Okay. So this is 90 degrees. So theta is here. Theta is here. Okay. This is R1. This is R2 radius. So from this one, so angle is here. Angle is nothing but sine theta. We have to find the sine theta. Sine theta is nothing but opposite side by hypotenuse. Then that value is nothing but opposite side by hypotenuse. Then we'll get that values. Okay. Then we'll get, draw the diagram. Then we'll get sine theta, sine of alpha by 2 here. Theta value is there. So alpha by 2. So this I'm taking the alpha by 2. So then I will get R1 minus R2 by R1 plus R2. Here this from this one. So then alpha equal to 2 into sine inverse of R1 minus R2 by R1 plus R2. Just if you draw the diagram, then you will get the answer easily for this question. Okay. Next. Option 1 is the correct one. Option 1 is the correct one. Next. 10th question. Question number 10. So if P and Q are the points of intersection of the circles x square plus y square plus 3x plus 7y plus 2p minus 5 equal 0, x square plus y square plus 2x plus 2y minus p square equal to 0, then the circle is a circle. Then there is a circle passing through the PQ and 1, 1 for exactly one value of P, all except one value of P, all values of P, all except two values of P. So if these two equations satisfies, then what is the p value is asking here only. So then that is nothing but, so here the equation of the required circle is nothing but s plus lambda s dash equal to 0. As for the family of circles, then we can go this one. So s plus lambda s dash is nothing but, you can take this, you can take this value is from these two. So s plus lambda s dash. So s plus lambda s dash. Then you will get x square of 1 plus lambda plus y square of 1 plus lambda plus or 3 plus 2 lambda of x plus 7 plus 2 lambda of y plus 2p minus 5 minus lambda p square. Okay. So from that one, I need which is passing through the 1 comma 1. Then which is passing through the 1 comma 1. Then you will get lambda value as this is, so this lambda value equal to minus of 7 plus 2p by 6 minus p square, 6 minus p square. So then if value is equal to 0, the value is equal to 0, then it will be a other circle. So it's become a second circle. So then p value, if p value is not equal to minus 1 by 2, minus 1 by, sorry, minus 7 by 2, minus 7 by 2. So then this will be there. This is a second circle. Then except one value of this one. So except one value of this one, then we'll get answer. So it is true for all except one value of p, except one value of p. This is a theory question. Just you have to do simplification on this one and the passing through this one, then you will get this lambda. So due to less time here, I did directly. Okay. So option 2 is the correct one. So next, if a point p has a coordinates 0, minus 2 and q has any point on the circles x square plus y square minus 5x minus 5 plus 5 equals 0, the maximum value of pq square. So then just we have to find this pq value. So see this. So solution of this one, let pq be a secant through the center pq. Then pq is nothing but cp plus r. Cp plus r. Required maximum value is nothing but 14 plus 5 root 3. Sir, how it, sir? How is it possible? So here now we have to find first option 2 is the correct one. So here given that 0 comma minus 2 is the point, and q is any point on the circle, that one. So then we have to find the center of the circle. So that is center is 5 by 2 comma 1 by 2. So cp, cp value is nothing but 5 root 2 by, so then you will get 5 root 2 by, okay Madhu, I will close it. Okay, thank you one and all. This is end of the class. Thank you.